Everyone, good morning. Let me introduce myself. My name is Kiki Kamaliah and my student number is 18, and today I would like to present my article review. Let's start it. The title of this article is Optimization of Biogas Yield through Co-digestion of Cassava Biomass, Vegetable and Fruit Waste at Mesophylic Temperatures. This article was published in International Journal of Renewable Energy Research in 2019. This article was made by Nathaniel Sawyer, Christina Troyes, and Dilahun Wagner. The volume is 9 and number 2. It contains 12 pages, starting with pages 771 until 782. The increase in urbanization and human population growth has resulted in an increase of demand for services such as electricity and waste management. The main source of energy generation in South Africa is coal. It accounts for approximately 74.8% of the energy mix. This, however, the coal is not environmentally safe. Based on the problem in the previous slide, to be able to solve it, we can use biomass as an energy source. Biogas that from part of the renewable energy is being mostly used in developed and developing countries such as Asia. One of the biomass that can be used as an energy source is cassava and organic waste, because they contain large amounts of fermentable sugar. The purpose of this research is to obtain the optimum biogas yield through co-digestion of cassava biomass, vegetable and fruit at different ratio in a single-stage fed batch and aerobic digester for biogas production. There are several steps carried out in this research. First, collecting cassava biomass and vegetable fruit waste. Second, inoculum preparation. Third, substrate preparation. 4, experimental setup. 5, experimental procedure and analysis method. 6, biogas yield collection. 7, measure the complex model. And the last, measure the co-digestion performance index or CPI. Next are the results of this study. First, substrate and inoculum characterization. Characterization is one of the most important steps in anaerobic digestion, as it gives the general composition of the substrate. The characterization of the substrate and inoculum show the physical and chemical characteristics of cassava biomass, vegetable and fruit waste, and cow dung. The second thing that is discussed in this article is daily methane yield at mesophylic temperature. In this slide, as you can see, show the daily methane yield of all the digester. Figure A until C show the methane yield of the plain substrate and a single digestion increase gradually. The next figure D until F show the methane yield of all the co-digestion feedstock decrease significantly after day 1. The maximum methane yield was reached on the 12th day. It was reached by the co-digestion of cassava biomass and fruit, vegetable and fruit at a ratio of 50-50. Okay, let's move to the next slide. We can see the figures show cumulative methane yield of monodigestion and co-digestion at different ratio. Co-digestion of cassava biomass and vegetable fruit with cattle dung inoculum at 40-60 ratio, figure F, produced the highest cumulative methane. It confirmed that biogas yield could be improved by co-digestion of the suitable substrate. Okay, in this slide, I would like to explain about the complex model. The complex model describes the cumulative biogas production curve in a batch operated digester. From the table, it can be seen that the highest cumulative methane yield is 1,641.8 ml of the C+ digester. C+ digester is digester containing biomass of cassava and vegetable fruit with a ratio of 40 to 60 and using an inoculum of 100 milliliter. Okay, the next slide is CPI or Co-Digestion Performance Index. From the picture, we can see that co-digestion of cassava biomass and vegetable and fruit waste residue with inoculum show higher methane yield, which is supported by the CPI of 1.264. There are two conclusions from this article. First, cassava biomass co-digestion with vegetable and fruit waste was successful in producing methane. And the second, the maximum methane yield was obtained from the mixture of cassava biomass and vegetable fruit with cattle dung inoculum at a ratio of 40 to 60. Okay, in this slide, we are going to talk about the advantages and weaknesses from this article. This advantages is the language used is easy to understand. And the second, the explanation of the methodology is quite clear. And this article compares the methane yield from monodigestion and co-digestion. And the weaknesses is didn't mention the timing of the study. And there are some spaces between sentences that are too far away, so they are not needed. And last, this is my opinion about the article. I agree that the cassava is one of the many biomass that can be used as a renewable energy source. Mixing cassava and vegetable and fruit can produce more methane. The condition of the co-digestion must be suitable for optimum methane production. This article can be used as a reference in making bioenergy and in developing countries like Indonesia. I think that's all. Thank you.